us put these kind of type parameters on type. So we could say this is a list of string, and then that would tell us that we've got a genuine compile error when we're trying to add a number into our list of string, okay? So we've taken errors which exist at runtime and moved them to be compile time errors, okay? So I need to get rid of that, and if I run it again, we can see we don't get any errors. So that's good, that's good. So there's definitely some value in generics. Generics weren't the only kind of approach to this kind of thing. So there's this kind of trilemma trade-off which I've been thinking about recently, which is this is a specific one for generics and type parameters. And the point is that generics give us that static safety that we can only add strings into our list of string, but we could also do another thing to do that. We could have a much simpler approach, which is to copy and paste a string list class and manually write it every time, or perhaps even have a few types which are generic, but not most of them. So this is simple and maintains that static safety, but it's not concise because we need to write our array list of string out every time. We can have the generics approach, which is statically safe and lets us have these more concise generic types. So things like Java, Scala, C# give us this, but it's not simple. And we also have dynamically typed languages, which are both simple and concise, but they don't have this kind of static safety. And I mention this as a kind of framing trilemma because there's a few things which are more complicated, and it's always worth remembering what the benefits are and those trade-offs are before we kind of look into them. So, the present. There's a lot of generics usage, and we'll talk a little bit about what people use generics for later, but I'm going to cover 3 specific features of generics, which are available in Java 5 or anything more recent, and they're kind of things which aren't so commonly used, but which are quite interesting in some ways. So I'm going to be looking at intersection types, what I've called the curiously reoccurring generics pattern, and we're going to be talking about bounded wildcards as well. So, when we talk about intersection for sets, what we mean is the element for the intersection of 2 sets has to be a member of both of those sets. And when we talk about intersection types, we see these kind of generic parameters, T extends A and B, and what that means is all the subtypes of A and B, our type has to be a member of. So why would I care about that? Well, let's suppose we've got this person here, okay? So our person class has a name and an age. And we've got a method that will read our person in and deserialize them from a data input stream. So they first of all read the name in as a UTF-8 string, and they read the age in as well. And we're using the Java 7 try with resources statement, so this guarantees that our stream gets closed after we've read in the person. So if I run this code, I've already got a file lying around, and you'll see there. So it's a character Don Draper from Mad Men, and he's now 89. Remember that show? Set in the 60s, he'd be a very old man if he was alive today. But our developers at some point in time want to make this kind of change to our code. So they want to also let us take a random access file as the input to read things off of. Over time, you may use different data sources. Now, what's the problem with a random access file is that there's no common interface between the random access file and our data input stream. So we could say, have a data input interface. So the data input interface has this read UTF and read int methods defined on it, but it's not closable. So this try with resources statement would generate a compile error. And in fact, what we've really got here is a situation where there's a missing interface in the API. Maybe you guys don't hit this specific one where you've got a data input and a closable, but often you might have a time where you want to say, I want something that's implements both of these interfaces, and there's no third interface which extends both of them. So what can we do? Well, we can use an intersection type, which we're going to call T, and we're going to say T extends data input and closable, okay? So T extends data input and closable. Now our parameter is going to be changed to be T, and our variable here is going to be changed to be T, and you'll see that compile error goes away. So we've managed to use intersection types to tell the compiler, even though there's not this common interface, pretend it's got the features of both of these things. and it'll still check because both our random access file and our data input stream have both of these things. So if we rerun this code again, we can see that the first time and the second time we've printed it out. So we've used the intersection type to work around a missing type on the interface. That's quite cool. But sometimes you see intersection types that look more like this. What's going on here? This is crazy. So what's crazy about this is we've got a type that extends both object and comparable of question mark super T. Why would you ever want to have the intersection of an object when you know everything's an object with something else? It makes no sense. This is genuinely the type of the collections.max method in the Java standard library. Well, what's actually going on here is before generics were added to the language, the type of that method returned an object. It took a collection as a parameter and it returned an object. And because Java maintains strong backwards binary compatibility, you have to make sure that under the hood, it still returns an object. If you made the return type this, like it's the same type as in the collection that we're taking as a parameter, then once the types are erased by Java-C, it would be returning comparable under the hood. So that would be a binary incompatible change. But if we use intersection types, we can ensure this kind of backwards compatibility at the binary level, because that intersection type will erase to the left-hand side of the intersection. So that's quite an interesting example there. Here's one which is, okay, there's quite a lot of code on that slide, but for the moment, just focus on the stuff that's in bold. We've got a method in Java 8 called comparing. And comparing is a factory method that builds us up a new comparator based upon a way of extracting keys. So it says, pull out the keys from both the left and the right-hand side and compare on the keys. Like, if you've got people, maybe your key might be, say, their age, and then you get a comparator by their age. Pretty cool. But some people want to be able to serialize the comparator that they get returned back. But you can't say, again, there's a missing interface. There's nothing that's both comparator and serializable. So under the hood, the library casts that lambda expression to be the intersection of comparator and serializable, which is like telling Java-C, look, go and generate me a serializable lambda, and then the comparator that gets produced from this is serializable. That's another quite cool use of intersection types in the core library. So, what about this guy here? Why is this happening? What's this thing doing? So we've got the situation where we see a class enum has got E extends enum of E. Conveniently, there's a good old Yodog meme for this. So we put a type parameter in your type parameter, so we could do what we're actually trying to do here. Well, this is what we've been referring to as the curiously reoccurring generics parameter. So we've got two person classes, and they're both of them are confused people, and we'll see why they're confused in a sec. John is an instance of confused person 1, and Bob is a confused person 2. And both of these confused people are clonables. Now, this clonable interface is generic. It's not the one in the core library, and it's got a single method on it called clone, and it returns that generic type. So you might think, we've added the generics, it's type safe. But actually, if we go back here, we've got a bunch of problems. So if you clone someone, you'd expect it to return the same type as you originally had, right? It's a clone, it should have the same type. But here, trying to reassign to that local variable, I've got a compile error. And the other thing you might be able to expect is if you clone someone and then you can clone them again. You can clone and clone and clone and clone. And that works fine for confused person 2, but if I want to abstract this to do cloning on anything, you'll see I get a compile error here. So what's going on with these things? What's the mistake that we've made in this design? Well, if we go back up to our clonable interface, we can add this recurring pattern to the template parameter. Because what we really want to say is anything that's clonable is generic, And when we return that thing, it's also clonable, okay? So the first thing this does is it exposes that our confused person 1 is confused because they implement clonable of string. So they're a person who, when you try and clone them, doesn't return you a person, it just returns a string. So let's fix that bug there. So this clone method should return confused person 1. And then we need to do that in the clone method, so actually genuinely clone ourselves. And now that's removed the compile error at the top, and the fact that this clonable method now returns a clonable thing means we can abstract over clonable as well. So if we run this code, we no longer have a compile error, but we're printing out John, which is really a clone of John, and we're printing out Bob, which is really the clone of Bob. So that is the what we've referred to as the curiously reoccurring generics pattern, where you've got something that extends itself and refers back. If you go to more formal academic literature, you'll see this might be referred to as F-bounded polymorphism, and that's just a useful term to Google. So, what about wildcards? Wildcards are situations where we see generic parameters that have a question mark in them. And there are really two forms of wildcards. There's unbounded wildcards, which are actually used quite a lot, and there are bounded wildcards, which are very rarely used. And we're going to be talking about bounded wildcards. It's weird because they're actually for completely different things, even though they've got a very similar kind of syntax. So, well, you might see things like this, say, in the Java standard library. It takes a question mark, extends t as a parameter. You've got, say, a binary search, and then you've even got things like this, where you've got question mark extends comparable of question mark super t. So things like that which get even more confusing. So, why do we care about bounded wildcards? And the answer is subtyping. So, if we've got a simple class hierarchy, so we've got a message, and we've got two subtypes of that message, yeah? So we've got an email message, and then we have, a text message for sending on the phone. We just want to write some simple code that uses them. So we've got a bit of an example here. I've got a method down the bottom that just logs a message. Now, if I log a message, I can pass in hi by email, and it'll run, it'll print out, and if I've got a text message, I can print out hi by text. As we all know, you can pass in those different subclasses as method parameters, nice and simple. But down below, we've got this more confusing situation where we're going to try logging a list of message. So let's see what happens here. Well, if we run log all and we pass in our messages variable, so messages was a list of message, this runs fine. But here we've got two other options. We've got email message, which is a list of email messages, and text messages. And the problem is that we get this compile error when we try and run that code. Now, to me, intuitively, that makes sense, right? I've got a list of message, and I want to do something with it. An email message extends message, so I want my list to extend the list. But lists aren't covariant, and there are potential confusions if we made them covariant in all situations. But what we can do is when we've got a method here like just logging them, where it's safe to do it for any subtype, we can use the extends keyword. So we say question mark extends message, and then we can pass in our email messages, and we run that, and we'll print out the email messages. And we've got text messages, and we can run it, and it prints out the text messages. So by using that wildcard, we've ensured that this is still safe. It's still only using messages, but we've allowed it to pass in the subtypes. Okay? Extends has a kind of a brother who's significantly less popular, which is super. And that does the exact opposite thing. So whereas extend says make this covariant, so it's subtypes if they subtype, a super makes it contravariant. It makes the types go the other way. So where's this used? Well, Java 8 introduces a bunch of functional interfaces. So for example, a comparator is something that you might already be familiar with, and it's modeling a function that takes two parameters, both of foo. And you might have a function interface in Java 8 as well, which takes a parameter foo and a return type bar. And actually, because with normal methods, as we saw earlier with that log example, we want to be contravariant on arguments and covariant on return type. We want to have it to be function question mark super foo and question mark extends bar. Okay? So even though the question mark super and question mark extends are features which are not that commonly used these days, the introduction of new features such as, or the use of functional interfaces means that you should actually be using these features a lot more in order to correctly type your code. When I say they're not used, I don't mean that as just it's my opinion. Some people have done empirical research. So this is a study that went on, analyzed a corpus of code. It's a few years out of date. And they found that 90% of generics usage was related to collections. So list of string, array list of integer, things like that. And the remaining use was mainly unbounded wildcards, so things like class of question mark. So this is a good evidence that people aren't actually using these features, even though they're there, and they have uses. Okay? So just to recap the things we've talked about in terms of the present section of this talk. Firstly, we talked about intersection types, and we talked about how we can use intersection types in order to simulate those missing interfaces. So an API was lacking something that extended to other interfaces, and we could use an intersection type to use that thing in our code. Then we talked about f-bounded polymorphism, the recurring generics parameter, which you see in every enum, but you can also use in your own code. And we looked at an example of how we can make something that's clonable be really clonable. And then we talked about bounded wildcards and how we could use them to make our subtyping relationship more flexible. Okay? So, let's have a little bit of a look into the future and at some of the other features which are kind of potentially upcoming in future Java releases. I don't work for Oracle. Even they wouldn't make any commitments on this kind of thing, but I think it's interesting to look at some of those features and what they can bring. So the first thing that's discussed for future reference is this thing called declaration site variance. So Java has use site variance, and what that means is when we say question mark super or question mark extends, that happens at the use of the type. So when we declare a local variable or a field. We can't write code that looks like this stuff on this slide. We can't write consumer question mark super t. And as I said on the previous slide, whenever you had a function with a parameter, it should always be super. So really for using any of the functional interfaces that were added in Java 8, you should have question mark super, question mark extends all over the place in your code. Now, that's very inconvenient because what it's done is it's taken the burden of getting your types correct and moved it from the library authors, who are paid by Oracle and thus need to be given more work to do, over to us day-to-day developers. And I don't want to have any more work to do. So by introducing the concept of declaration site variance, we can say something like anything that's a consumer or anything that's a function, it'll always have a covariant or contravariant parameter. So this question mark super would be a contravariant example. If you want to read more about this topic, there's a JEP on the OpenJDK project. Quick hands up, who knows what a JEP is? Cool, that's like 3 people. Fantastic. So briefly, a JEP is a JDK enhancement proposal. So it's like a document that says, this is something we're planning on doing or thinking about doing, and there's a bunch of them listed on the OpenJDK website. So if you ever want more information about what features are being prototyped or looked at and moving forward with Java, and you want to see what's coming up, the JEPs list is a great place that you can go and find out more information. And if you've got a question, you can always email one of the OpenJDK mailing lists. But that's the declaration site variance JEP. Another thing that's coming up, and this is perhaps a little bit more concrete than declaration site variance, is the idea of primitive specialization for generics. So there's this kind of big proposal to add value types to Java, which is like a Java 10 feature. So quick hands up who's heard of the value types proposal. Okay, a few people. So the idea with value types is that we have a separate group of types in Java that we can code like a class, so they have behavior and values and things like that. But they work at runtime like an int or a long, so they don't have identity. They aren't located arbitrarily somewhere in your heap. They're contiguously aligned in memory. And there's a lot of potential performance advantages which work well with the way modern memory layout works. So that's the overall value types proposal. Now, this affects generics because it means that you might want to have something like a list of a generic type or even a list of int. So here's some code example I've got here where I've got list of int, numbers is new array list, and then I'm adding those two numbers. That's not syntactic sugar for list of integer. With a list of integer, you've got an array and then a bunch of pointers to all these integer objects which are all boxed all over your heap. This is genuinely a list of int, an array with the ints in line with the array, using up 1/8 of the amount of memory on a 64-bit JVM and making your CPU's cache prefetcher a lot happier and a lot faster. There's a very complicated proposal there called the specialization proposal, which is quite an interesting read if you want to look at it in more detail, and that's part of Project Valhalla. So Valhalla is the project to investigate value types and associated features, such as allowing you to have specialization of generics. Now, one caveat with this proposal, which makes it a little bit harder to adopt, is the idea that you won't be able to just take a normal generic type and make it work with ints or value types, because normal generic types get erased to be some kind of object, and objects have identity, they have reference. You can do things like synchronize on an object, use the synchronize keyword, which you probably won't be able to do on a value type. And this proposal doesn't mean that you can take any arbitrary generic class and use it with primitives. You have to do what's known as anyfy the type. So you have to say this is this generic parameter could be any generic, and then there are certain restrictions imposed. So for example, you can't synchronize on it if it's an any type. Cool. There's a lot of other kind of generics features or things which are of interest. So I mentioned bounded wildcards. There's obviously unbounded wildcards and type bound, so like t extends, blah, 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 blah. Erasure is one of those topics which has been talked a lot about when it comes to generics. So erasure means at runtime, we don't have a list of integer anymore. We've really got a list, and a lot of these generics features are implemented in Java C, and information's thrown away at runtime. That has a lot of problems. Hopefully the main problem that people find with it is the performance downside and the memory overhead downside of things like boxed integers in your array list. And that should be fixed by the Valhalla proposal. There are also some advantages that Erasure has which are probably not commented upon, which is, for example, really good interaction with other languages on the JVM which are dynamically typed. There are currently a few ways you can beat the static safety in Java. So for example, you can take a value that's not the right type that you want to put in it, upcast it to an object, and then back downcast it to a generic type to throw in there. And that kind of problem I don't think is ever going to go away, but it's something to think about. The other thing to remember as well is that whenever kind of changes are made in Java or features are added, they're rarely added in isolation. And it's hard to think of, with the possible exception of wildcards, features which were popularized by Java but not brought in from other languages and other areas first. So it's always worth remembering that the existing body of information on types from other languages is useful for Java. If you're interested in any of the source code for the demos or samples I showed in this talk, they're on GitHub at that URL. So, in conclusion, there's a bunch of features that we have with generics in Java that are kind of underutilized. They're there, they have usage, they have things that we can do with them, but we don't really use them. But as we change our use of Java over time, so for example, more functional interfaces might be a good example of the kind of thing I'm talking about here, our usage patterns of those features can change. And it's worth thinking about how we can use those features today, even if we haven't used them so much before. As Java, the language, evolves and as the library ecosystem continues to grow, there's a lot more complicated generics usage. Some of the stuff in, say, the collectors framework in Java 8 is exceedingly complicated. And it's always worth remembering that we need to kind of refresh historical knowledge in order to understand these more complicated use cases. But it's not necessarily a problem. Most of the complexity burden of this kind of thing is really on people who are writing libraries with Java rather than application development. But in summary, a lot of the complexity that we see from generics before, and also moving forward with things like the primitive specialization, is really a result of trying to maintain backwards compatibility. So it's a benefit we all receive, but it's a price that we all have to pay in terms of continued complexity in things like generics. I'll give you guys an opportunity to ask me some questions in a sec. As I mentioned on my Java 8 talk yesterday, I run a Java 8 course and was the author of the book on the right-hand slide there. My friend Raoul, who's also contributed these slides, wrote the one on the left, and I also put some courses up on Pluralsight, including an upcoming course on generics that goes into these kind of topics in more detail. So thank you very much for listening. I hope you enjoyed the talk. And if anyone has any questions, I'm happy to take them now.
Several words about the primitive specialization.
Yep.
Does it mean that actually the primitives will be allocated in heap, which currently is a nonsense?
So the point about primitives is that hang on, what's the question again? You're trying to say
that actually the list is an array list as an object is still in heap, not in stack, but it will contain primitives, and so we have the strange situation that primitives are in heap.
Right. Okay, I get your question. So if you think about what we have at the moment, is we don't have a situation where you've got references to something like an int on the heap, but you still have int values located on heap memory. So if you've got something like a boxed integer, that's got a field, and that field is a primitive int. And that field is therefore a primitive int that's lying somewhere in heap memory. If you've got a primitive specialized array list, so an array list of int, somewhere inside that array list you'll have a reference to an int array. And that int array will just be a regular int array that's going to live on a heap like any other, like if you did new int array, blah, 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 today. Okay, so does that make more sense?
Yep, gotcha, thanks.
Thanks. Any other questions?
Maybe expect any improvements in compiler messages for errors in some lines of code. Something wrong with these generics?
Well, that's a very good question. So do you want more improvements? Yes, so do I. So it's a fair point. Oftentimes you see generics compile errors and they're very confusing and hard to read. So I don't know, have you tried Java 8 at all? 8? Have you tried 8? Yeah, so one of the things you might notice with Java 8 is they've actually improved the generics error messages, because with the new addition of a lot of generic types for things like functional interfaces, it was becoming more problematic. And what they've done with the generics error messages in Java 8 is given you things like, look, we tried to fit a type that looked like this into the parameter and it didn't work, or you've got multiple overloads with different combinations and it didn't work in these kind of situations. So they've added more detail to it, which I hope will continue to improve in the future, but I don't know of specific proposals as to help that kind of thing. But I do agree with the premise. I think they could be better. Okay. Are there any other questions?
It's a more general question. Few people in this conference mentioned the project Valhalla. And
Yep.
There is a lot of talks about value types and
Yep.
all this stuff. What is your personal, what do you think about value types in Java? Because Java is all about objects, maybe it's becoming more functional, and value types are more primitive and low-level things. What do you think about all this idea?
So I think it's a good question, thanks. So the question is, what do I think about value types? Aren't they divergent from, say, the changes in 8? So there's a few things to think about value types. So one of them is the current proposal for value types means they're all immutable. Okay? So having value types be immutable is fundamentally a very functional approach. So that's one thing that does fit in with kind of functional programming aspect. The other thing to think about with value types is they are in many respects offering a way to model a certain, I don't want to say class, like a kind of a group of types that don't have identity. So they don't have unique individual identity. And that fits very much with the kind of functional programming mindset of pull values in, return values out. So I kind of see value types as being something that fits a lot in with the kind of functional programming mentality. One of the reasons why people don't like some of that values in, values out stuff in terms of their production code is they often view there as being a little bit of a performance overhead from having allocation of things on heap, boxing, stuff like that, which value types should reduce. So it's also one of those things where it's made some of those idioms more practical and more useful. I wouldn't say that they're necessarily a more low-level construct than a class is, in the sense that, I'm obviously kind of crystal ball gazing here. We don't know what the final spec will look like. But in terms of what's being discussed and proposed, they're things which should code in the same way as a class. So they're things which you should be able to have methods on, they should be able to implement interfaces, you should be able to abstract over the interfaces, things like this. So it's you're getting something which has some of the performance benefits of, so at the moment you've got this kind of primitives which are really low level and we can't deal with, or objects which have identity and have performance overhead associated with them. And they're trying to get something which has some of the performance, memory, layout characteristics of primitives, but with the coding, higher level usability characteristics of objects. So to me, it kind of makes sense. There are, so I don't know if you went to like Volker Simonis gave a talk yesterday, it pointed out that there's kind of packed objects, value types, there's object layout proposal. The object layout proposal as well, I also think has a lot of kind of merit for people who've got existing Java objects and want to have layout control. There's some good stuff in there as well. So I don't want to say, well, I mean, my personal opinion is it's not an either-or situation either. Both of them could be added. But I think there's a lot of good stuff in value types, and I'd like to see value types, probably value types and the object layout proposal be included at some point. Okay? Cool. Any other questions?
Thank you, and I have a question. Why do you think it is impossible to put a list of apples into the list of fruits, but on the other hand we can do it with an arrays?
Right. That's a good question. So the question is why are arrays covariant and why are lists not covariant? So how can I put this? morally, arrays shouldn't be covariant, okay? Because that introduces a bunch of potential type safety issues. So it's reasonable for lists to also not be covariant. Why are arrays covariant? I genuinely don't know. It was clearly a mistake, and I guess I suspect it's just a, you know, early days of Java, not enough review mistake that you know can't be corrected with hindsight because it would break compatibility. So it's one of those things that's always going to be broken and sucky. But yeah, the list way is definitely the right way, and if you want to abstract over them or use them in a covariant case, as I say, wildcards lets you do that. So, yeah. Any other questions? Okay. Thank you very much.